Okay, so Notes 5.3 is about adding and subtracting radicals, and we just finished lesson 5.2, which was multiplying and dividing. And I will say this is going to go much faster because you now have the experience of simplifying radicals, and we practiced that a lot in 5.2. So in these first couple examples, what we're going to do is we're going to take a look at if you were asked to add 1 radical 3 plus 2 radical 3, since the terms are like. Now this is really not any different than if I ask you to add x plus 2x. You are allowed to add because these terms are like. So a 1x plus a 2x equals a 3x. Okay? What happens is you are allowed to add radicals as long as they are like. So as long as the radicals are the same root, these are both square roots in example A, and they both have to have the same number, variable, and or expression underneath the radical. So a 1 radical 3 plus 2 radical 3 is 3 radical 3, and you're done. Okay? Now, in part B, just because the radicals don't look like they are like, you cannot add them up. But you can't just say, oh, I'm done with part B, because what if one of them is not simplified? Now, I did the work down here, but I'm going to kind of show you here, kind of do it live with you, and then you can always follow along. But because 2 is underneath, there's no perfect square that goes into 2, so 4 radical 2 can be left alone. But we know that can be written as the product of 4 times 2, because 4 is a perfect square. So the square root of 4 is 2, and then we're left with radical 2. So in reality, this problem is really just 4 radical 2 plus 2 radical 2. Now the radicals are exactly the same, so you add these coefficients in front. And 4 plus 2 is 6. We have like 6 radical 2's. So it's almost like you have 4 x's, here we have 6 radical 2's, okay? So if you can simplify and get radicals to be the same, then you can add or subtract them, all right? Now, I wish it was always going to be that simple, but sometimes we're going to have variables and different things that we had, kind of like in our notes last section. So here we go. For number 2, we have 5 radical 7 minus 2 radical 28 plus 6 radical 23. I'm hoping by now you know how to simplify these, but I know that, of course, where'd you go? I know that 5 radical 7 is already simplified. So I'm going to go ahead and just write down 5 radical 7. And then I need to figure out, is there a perfect square that goes into 28? And there is. And the biggest number that is also a perfect square is 4, and that goes in 7 times. So I'll come back and finish that in a minute. And then, is there a perfect square that goes into 63? Absolutely, that's 9, and 9 times 7. So once again, we're not changing the value of anything under there. We're literally just getting ready to kind of break it up. So now that we have things kind of underneath the radical that we can take the square root of, I'm going to have 5 radical 7 minus 2. The square root of 4 is 2, so that's 2 times 2 radical 7, plus 6, that was out in front anyways, times the square root of 9 is 3 times radical 7. So basically I have 5 radical 7 minus 4 radical 7's plus 18 radical 7. Now ironically, not a shocker, all of these have the same radical, square root 7. So 5 minus 4 is 1, 1 plus 18. Your final answer would be 19 radical 7. Okay? All right, let's go on. Now, in our last section, we really practiced a lot on making sure you could handle variables underneath. So right now we have a square root of 9y to the fifth. Well, I know I can take the square root of 9, but since y to the fifth is not divisible by 2, our root of 2, I'm going to write this like we did last section as y to the fourth times y to the first. Okay? Now, minus y, I'm going to write y to the third as a square, y squared times y to the first. Once again, I haven't changed the value of anything. I'm just writing it as factors so that I can break it up. Okay? Now, here we go. The square root of 9 is 3. The square root of y to the fourth is y to the second. And then we're left with square root of y, that's a 1 right there, y to the first, minus y was already out front. The square root of y squared is y, and then we're left with radical y. So we have 3y squared radical y minus y times y is y squared radical y. Well, they both have the same radical, and we have 3y squared minus the 1y squared, so your final answer here would be 2y squared radical y. Okay? Now, if you try to simplify one of these expressions and you don't get the same radical, then don't force it. You might just have to write them as separate. So you can't, for instance, you cannot combine, let me see if I can get my pen to work here. You cannot combine an x and a y. So you would leave it as x. So if you had 2 radical 7 plus radical 3, there is nothing you can do to simplify those. So your final answer, you would leave something like that. So don't worry if you encounter that in your homework or in your notes. Okay. All right, let's wrap up the front. So number 4. All right, we, as of right now, don't have anything under the radical that's the same. So I always suggest simplifying first, okay? So I'm going to have 12 times the cube root of 2, and then I'm going to break up z to the fifth into z to the third times z to the second, okay? Minus z, cube root. There is a cube number that goes into 54, and that's 27, and that goes in 2 times. So 27 times 2, and then I can't really do anything with the z squared. So once again, now we kind of go to work, and we see what is it that we can kind of simplify out. So we have this 12 sitting in front. We can't take the cube root of 2, so I'm going to bypass that for a minute. The cube root of z to the third is z. Can't take the cube root of z squared. So underneath this cube root symbol, we still have a 2 and a z squared. Over here, I have the z out front. The cube root of 27 is 3. Can't do the cube root of 2 or z squared. Now, we don't like to have z times 3, so I'm going to write that, with the coefficient in front. So we have 12z cube root 2z squared minus 3z cube root 2z squared. So 12z cube root 2z squared minus 3z cube root 2z squared gives us a final answer of 9z cube root 2z squared. All right? And that's kind of the basics. I mean, there's really not much else we're going to do. So what I would like you to do is the best thing is to do the following 6 questions on your own. So if that means you want to do all 6 and then watch the video and check them, or if you're getting them right, then you can kind of fast forward through the video. If you're getting them wrong, then I would slow the video down and make sure that you know what you're doing, okay? So push pause, do the 6, and then come back and check. All right. So now that you've tried these, you can check, and hopefully you're kind of watching what I'm doing here, and this is becoming kind of, a little faster. but our square root would be 2 times 3 radical 6. So you should have taken 6 radical 6 minus 11 radical 6, and your final answer here is negative 5 radical 6. Number 2. Ooh, I like this one. They already have 3 radical 11 and cube root radical 11, cube root 11. So they already match. So 19 minus 3, your answer is just 16 cube root 11s. That's great. That one's good. Number 3. We have 13 times the cube root of 3. And we need to simplify this. So you need to ask yourself, what cube root number goes into 375? Well, if you did this right, that would be 125, and then that went in 3 times. So I'm going to have 13 cube root 3 minus the cube root of 125 is 5 cube root 3. So 13 cube root 3s minus 5 cube root 3s is 8 cube root 3. And hopefully you got that. All right. The last 3, and then we'll move on. Or you can move on and make sure you're reading the agenda to see what's next. Number 4, we got fifth roots. We don't do a lot with fifth roots, so you might have to type in, 2 to the 5th is 32. What's 3 to the 5th? What's 4 to the 5th? To try to find fifth root numbers that go into 486. And really it's trial and error, so use that calculator if you need to. So when I was doing trial and error, I found that 243 is a fifth root number that went into 486 2 times. And you'll notice there's nothing really to do with this number over here. So the fifth root of 243 is 3. So we have 3 times the fifth root of 2 plus 10 fifth root 2. And if you can add those up, which you can, that gives you 13 times the fifth root of 2, and you're done. Okay. Number 5, I'm loving number 5, just like number 2 above. This is 12 cube root y and a 9 cube root y. They already have the same root with the radicand, which is what's underneath. So we can go ahead and add them. 12 plus 9 is 21 cube root y. Love it. All right, last one. Check yourself, make sure you're good. Number 6. I can take the fourth root of 16. So 16, the fourth root of 16 is 2. So obviously we can't take the fourth root of w, so that stays underneath. And then this one is already the fourth root of w. So that gives us 5 times the fourth root of w. The one thing before I kind of wrap it up that I cannot stress enough is make sure you are writing your roots kind of attached into the front of the radical. If you leave this 4 off in number 6 right here, then it's going to say 5 square root w, and that would be wrong. So please pay attention to how you're writing your root, or what we call the index, and that you're not leaving that number off, okay? All right, that's it for your notes for 5.3.